Good afternoon to everybody. My name is Oksana Markiv. I would like to present our teamwork compensatory method for measuring phase shift using signals, Bisemiperiodic conversion in diagnostic intelligence systems. In our research, it dwells upon phase shift determination method using total signal obtained as a result of summing up two harmonic signals after carrying out Bisemiperiodic transformation. Value of phase shift has been determined by comparing vector obtained after amplitude time analog digital conversion of total signal with a set of reference function vectors. Maximum value of correlation coefficient has been used as criterion for specified vectors. Criterion for specified vectors coincidence. Algorithms for finding the maximum correlation coefficient has been developed, and main error sources for proposed method for diagnostic and determination of modern weapons and military equipment state will allow to reduce requirements for measuring equipment without reducing accuracy of measurements. This slide, there is demonstration what is subject of our study, the aim of research, and main tasks of research you can see from slide. Apparatus for conducting factorial experiment is like basis for compensatory method implementation. In our work, compensatory factorial experiment, it is the choice of the ratio which the most fully describes the shape of curves, total signal obtained as a result of the summation of two harmonic signals after conducting two semi-periodic transformation. Main aspects are depicted here, and the main purpose of the work is to develop compensatory methods for measuring the phase shift, which allow to reduce the measurement error during technical condition diagnostic of modern weapons, as I have said, as well as to reduce the cost of measuring equipment in intelligent diagnostic systems. Under Bisemiperiodic conversion of input signals, we mean that input sinusoidal signals turn into two semi-periodic ones with further summation. By form of the received signal is determined the phase shift. The operation of transforming of sinusoidal signal into two semi-periodic may be done with the help of diode bridge or diode resistive converter. It is needed to consider measurements procedure by measuring harmonic signals phase shift, and this slide demonstrates time diagram for signals. The first picture and the second picture also demonstrates time diagram for signals, but after auxiliary operations. Time diagram for signals which have certain phase shift relative to each angle is shown here, and after auxiliary operations, the second one. After performing amplitude time analog digital conversion, it is possible to obtain such a vector demonstrated on this picture. Yes, this vector is possible to obtain after performing amplitude time analog digital conversion. And in order to reduce computational operations and simplify procedure, it is advisable to switch from time counts to signal phase counts. What is depicted here, this formula, and the more precise descriptions of our calculations you can receive in our article. And here are just some main points. And here you see discrete reference functions when signal is equal to 0. Experimental part of the research is demonstrated also in this slide. Taken into account the above mentioned, it is needed to formulate phase shift in such a way. So the ratio for determining this value in special case is as follows, demonstrated here in this slide. And in this place, yes, taking into account the above mentioned, it is needed to formulate the measurement tasks of phase shift determination of both signals as follows. From entire set of reference functions of phase shift, it's need to choose functions that will provide maximum value of correlation coefficient between it and the discrete signal demonstrated here. So here there's depiction of algorithms for finding the maximum using Golden method. And it looks like this. It is combined by previous stage, what means determination of admissible final length of uncertainty. Length of new uncertainty interval for the first iteration is determined using the ratios given in the work here. And there is explanation and also main stage that consists of 4 steps. Step 1 is depicted. The second step, the step number 3 and the step number 4. And in the result of research, we can distinguish such main sources of error in phase shift measurement as error due to formation of measurement interval, due to presence of noise interference caused by amplitude time transformation, due to non-identity between characteristics of the first and second measuring channels, rounding error when searching for the maximum value of correlation coefficient, and error of the reference function formation. So conducting experimental research with obtained numerical values is planned after completion of work. So such assessment of our work can be received after all full calculations, after numerical values planned after completion of work, and the synthesis of the calculation methodology requirements, computational equipment, and software. The result method of measuring phase difference can be attributed to compensation method has been proposed, algorithms for finding the extreme functional dependence, main sources of error, and further work will be devoted to the practical verification of the obtained results using physical model of proposed method of phase shift measurement, and proposed methods of measurement and diagnostics can be built in artificial intelligence system of diagnostics to determine state during its operation and maintenance. So thank you for attention and ready for your questions.